Okay, so here is our standard common source amplifier. And what we're going to do is we're not going to worry about vising it with resistors. We're just going to say I have a DC voltage source, which we're going to call VB1. And then we have an input V in, so this is all biased and everything looks good. So what we want to do is we want to take this resistor here, and resistors tend to be really large for integrated amplifiers. And so what we're going to do is we're going to replace this resistor with a different transistor. So we're going to have two versions of this. So let's start with the first one up here, where we're basically going to come in here and just use another N-type amplifier, or N-type MOSFET, I mean. So this was my VB1, this is my VN. Up here, I'm just going to add in a different bias, which is VB2. Okay, now the other way that I can do it is I can come down here and replace it with a P-type MOSFET. So in this case, let's go ahead and replace this with a, so we could be consistent. So you see we have these two configurations. So the one is we're using two N-types. The other one we have a P-type and we have an N-type. Okay, so in this video, we're only going to be talking about this first one. So we're not going to be dealing with this one. We will do that one in a different video. Okay, so what we want to do is we have this one. So we have the source of this one connected to the drain of that one. And then the output is connected between both of them. Okay, so what we want to do is we're going to start with the top one and look at the small signal model of the top one. Okay, so we could go through and do the small signal model of the top one, or we could just use our little equation sheet. So let's go over here and look at our equation sheet. So on our equation sheet, okay, here's what we have. So we are looking into the right in here. So right here, we're looking into the source. So if I look into the source, I get 1 over GM. So now we're going to come in here, and you see that I'm going to have one over GM2. And then this is my VB1 and my input source right there. Okay, so we basically took that top transistor, and replaced it with a resistor. Okay, so now when I do my small signal, now when I do my amplifier, again, I'm going to go back to my equation sheet. I'm going to look here. So now it looks just like this one right here, except for my RD is getting replaced with this 1 over GM. So now my gain is going to be equal to minus 1 GM1 times V in times the resistor, which is going to be equal to RO1 in parallel with 1 over GM2. Now, most of the time, now these are going to have different parameters, but for the most part, this is going to be much, much larger. And so then when I'm done, I have A is equal to minus GM1. Oops, this gain got moved over to the other side. Times 1 over GM2. So my gain is equal to minus GM1 over GM2. Well, that seems kind of odd. So if I plug in what these are, this is equal to 2kp1 ID over 2kp2 times ID. And then we square root. If I look up here at this part right here, they're going to have the same current going through them because they're in series. So that's why they have the same current. So this is going to be equal to minus kp1 over kp2. Which, if they're identical transistors, that's just going to be 1. I don't get any gain and nothing really happens. But since I can scale my transistors, this is going to be equal to, so typically when we're doing things, we're going to get a mu n C aux. It's the same for both of them. We're going to set L1 equal to L2, but then I can adjust my two widths. So this is going to be equal to mu n Cx W1 over L1 over mu n C aux W2 over L1, which is equal to W1 over W2 square root. Negative, negative. So you see now I can just adjust my gain by changing the relative sizes of the two transistors. But now what we see when we go up here is we got rid of our resistors. And so what ends up happening when I have an integrated amplifier, the transistor is going to be much smaller than an actual resistor. So this one I eliminated a resistor and replaced it with a transistor to make a much smaller design that I can integrate everything together. And when we're all done, you see this is my gain. And that is the first type of amplifier.